Some of you are still confused about the direction of moments, so I decided to make this short video about it. Let's say that we have a block that looks like this. It's uniformly distributed in weight, and we want to find the moment of this block around the midpoint A. Let's call it A. So that point is right in the middle of the block, and there also happens to be a force acting on this block on the left side. Let's call it F. Now remember, the moment is the tendency for an object to rotate around a point or an axis. So in this case, with our force F on the left side and our point of rotation A here, we would expect that this block would actually rotate like this. Now that line that I just drew, that rotational line, is not the direction of the moment. I know, that's a little confusing. I'll repeat that. This line that I just drew, the rotational line around A, is not the direction of the moment. The actual direction of the moment must be found using the right-hand rule. So what is that again? That is, if you take your right hand and you curl the fingers of your right hand in the direction of your expected rotation, then your thumb will actually point out at the direction of the moment. So, what does that look like? I'm going to draw probably the ugliest hand that you've seen in a while, but please bear with me. Like that. So, as you can see, hopefully, the fingers of the right hand curl towards the left in the same direction as the rotation. And when you do that, the thumb actually points outwards from the screen, which means that you get a line that looks like this. This line here, from the point A into the direction of the thumb, this is the direction of the moment. So let me repeat that. This rotational line around point A is just the expected rotation caused by your force. It is not the direction of the moment. The actual direction of the moment is the straight line that comes from A in the direction of your thumb. So, what does that mean for you? Well, firstly, when you write out an equation like this, where the moment is equal to r cross F, this formula is actually giving you the direction of this line. So that's the first thing. Now, more situationally, if you're ever asked for the moment about an axis or about a line, let's use our typical X, Y, Z axis as a sample. Let's say you were asked for the moment about the x-axis. Well, that means it's the rotation around the x-axis, which means that it can only either be like this or like this. Now, if we use the right-hand rule in each one of those cases, we'll see that the moment direction for each one can only either be like this along the positive x-axis or like this along the negative x-axis. So that means that your final answer should only have an I component because the moment direction only acts in the x-axis or the I direction.